morning, grade 12s. We are looking at the workshop questions on geometry. This is 3 recorded lessons, and this is the first one that we're going to look at now today. The surface area of a sphere is given with this formula. So they provide you with a formula. You don't need to learn it. Calculate the surface area if the radius is 5. So I'm just going to substitute 4 pi 5 squared. And now I must do that calculation on my calculator. I like to start there with a square, not to make a mistake. So it is then 5 squared times, and at the bottom of your calculator you will see there is that symbol P, but we need to use shift pi and then times 4 is equal to, and I have 314. 314. You can give it in terms of pi, but you can multiply it out also. The second one is actually algebra, where we have to change the formula, but this is why we are doing it. And R must now become the subject of this formula. So to have R alone here, I'm going to divide by 4 pi is equal to R squared. And then in a second step, to get rid of the square, I root it, which is the opposite operation. But what I do on the one side, I must do on the other side. So I'm going to square root this one, but I also have to do it here. So it is A over 4 pi, which is equal to R, changing the formula. You do with the letters what you do with the numbers. Right, question 2. There's a running track, each of length 120, and then 2 circular ends. Now, the first one is calculate the total length of the curved sections of the track. It is a 400-meter track, so then it's 400 minus twice 120. And they want the total length, so we don't need to divide it by 2. So 400 minus twice 120 is then 400 minus twice times 120 is equal to 160 meters. And then they say calculate D, the distance between the parallel straight sections of the track. Now, this is, because it is the 2 curved surface areas, this will form a full circle. So that means that that is actually the circumference that we have there. So the formula that we will use here is circumference is 2 pi r. And we know now that the circumference is 160. So to have r alone here, we will divide by 2 pi, and you divide by 2 pi here. So on your calculator, let's press the calculator, 160 divide by brackets 2 times shift pi there at the bottom of your calculator, close, is equal to, and now I have now 25.46. 25.46, but now remember, this is the radius, and we want the diameter. So we'll have to multiply that radius by 2. So the final answer for this one is then 50.9. 50.9. That is the final answer there for number 2B. Number 3. Calculate the size of one exterior angle of a heptagon, giving your answer to 1 decimal place. Now we know all polygons, for all polygons, the exterior angles are 360 degrees. A heptagon is a 7-sided shape, so we just divide it there by 7, the exterior angles, and it is then 360 divided by 7, and the answer is 51 51.4. 51.4. Right, the next B part of this question, we've got parallel lines, so that means we have co-interior angles, alternating angles, and corresponding. In the diagram, there's the parallel lines, and we've got that this angle is 130 degrees. What is the special name given to this triangle? And we can see that this is an isosceles triangle. An isosceles triangle because we've got two equal sides there. And now we have to calculate all the angles here. So P is going to be, this is a straight line, 180. So P is going to be 50 degrees. Because it is isosceles, R must also be 50 degrees. Can you see? P and S are alternating here. So this one is also 50 degrees. We've got a straight line here. If this is 100, it means T is going to be 80 degrees there. And here in the triangle, or working with alternating angles here, this one is also 80 degrees. So there are then the sizes of all the angles. Right, the second one. We've already done that now. There's a circle. What do you know about a circle? We know that the angle in a semicircle is 90 degrees. That's what we know. So this is a triangle then. So these two must also add up to 90 degrees. And that gives me then 90 minus 65, which is 25 degrees. 25 degrees. Question 4. The diagram shows a swimming pool with cross-section A, B, C, D, E. The pool is 6 centimeters long. So here you've got a nice picture of how it looks like. Calculate the area of the cross-section here. This is the one that we have to calculate. We don't have a straightforward formula here, so we'll have to divide it into two areas. Here's a rectangle, and then this one is a trapezium. So the rectangle here will then be 2 times 3.6, the rectangle there, but now we'll have to calculate the trapezium on this side here. Now, if you turn it around, you'll see that this is actually your parallel lines, and this is the height that we have there. That's the height then there. Now, if this one is 3.6 and that one is 6, it means this part here is also 3.6. So we can subtract the two there from each other, and then we can see that this one is then 2.4. Yeah. That part there, the height there is 2.4. So this is also 2 meters there, and this one is 1 meter. There we can see it's 1, and this one is 2. So this is a trapezium. The formula for a trapezium is half height A plus B. So this is then going to be a half of the height, which is 2.4. And A plus B are your two parallel lines, which is 2 plus 1. That's how you calculate that one then there. So the total area is 10.8. 10.8. This one is 6. let's start with that question 69. This was a very easy question. A company makes two models of television sets. Model A is a rectangular screen and model B has a larger one. It's increased in the ratio 5:4. Calculate the new measurements. Now that is very, very easy. This is then question 69. Because what do we do if we enlarge it? You just put your ratio 5/4. It's not sharing, because that's what some learners do. It's just the bigger one which comes on top. And what is the new dimensions? Yes, and? Yes, that's the two new dimensions, yes. No, it doesn't work. Yeah, but it must be in the ratio 5:4. What happens with this increasing of a ratio, it's an automatic increase. It automatically increases if we work with this one. So this is how we need to do it. And then they say the area. What is the area? Now, what do you know what happens to the area? Yes, what? This ratio, isn't it? So, ek wil nou net kyk, but look what they say, A to B. So it's the small one to the bigger one. So it is then 4/5, which we square. Ek dink hulle sê give it as a fraction. Yes, so it's 16/25. 16/25. Easy question, but you forget this. Oh. Okay, question 68. Calculate the area of an equilateral triangle with sides 10 centimeters. There's the equilateral triangle. Now, there's two ways. But what is? Okay, so you can work, but then remember that one is 5. So I can half base height, calculate that side, and then get the area. Or you can work with any triangle, half BC sine A. And we know that an equilateral triangle is 60 degrees. So that's another method to do it. The answer on that one is... Oh, 8. 43. You need to calculate the heights first. So it's 43.3. So it's 10 squared minus 5 squared to get the height. And then it's half base height. Or you work with half BC sine A. Again, lots of learners had this wrong, which is unnecessary. Okay, now, number B. Calculate the radius of the circle with circumference 10. That's very easy. Circumference is 2πr. And you just calculate R. R is 1.59. Okay, but we're going to use this now in the next question. That's why I write it down. But that's that's a question that we ask grade 9s. Then number C. The diagram represents the nets of 3 solids. Each straight line in each diagram is 10 centimeters. Each circle has a circumference of 10, and the arc length in diagram 3 is also 10 centimeters. So name the solid with the net 1. Luan, what is that? 1. Diagram 1. You must tell me. What is the name of the first diagram the solid? Wat noem ons hom? Yeah, but that's not good enough. Pyramid is not giving triangular pyramid or a tetrahedron. Yeah, a square based, a pentagonal, you get a lot of pyramids. Jy kry nie vir pyramid 'n punt nie. A triangular pyramid or a tetrahedron. Nee, daai een is die tetrahedron. Daai een is die tetra. It's a square-based pyramid. And then, ja, maar dis hoekom ek sê, jy moet sê, dit kan ook 'n punt wees, né? Look at that one. Then, calculate the volume of the solid whose net is diagram 2. So what will this be? What is the volume of the cylinder? What? 2PRH, isn't it? Yeah, the volume. Oh ja, excuse juffrou is nou by surface area. PR squared H. Nou nie my liedjie vir julle hier oor die ding sing nie, so. Okay, and it is 79.4. I use this radius length that I got here now, and it's then 79.4. So very easy, very, very easy. But let's look a little bit at number 3. Calculate the perpendicular height of the solid whose net is diagram 3. So this is a cone. It's a cone that you have there. Look that they also say the arc length is also 10 centimeters. So how will we calculate that perpendicular height now there? But this is an arc length. Okay, so with Pythagoras, which two sides are we going to use? 10 squared minus that 1.59 squared. The radius, minus the radius. And the answer was 9.87. Okay, so that was last year's 2 questions. I think daar's nog een, hè? Number 67, which was the Loki. Okay, look at question 66. Yeah, daai ene. If you look back, number 10, exactly the same question. It was number 10. Okay, so I would also ja, maar julle kry dit. Give reasons, explain why triangles QOT is similar to QRRS. So why will they be similar? So you have to look at that. You always have to show Q is equal to Q. Y is O equal to R. This is corresponding, and T is equal to S is equal to 90 degrees. So this is a common angle. Q is a common angle, and this too is 90 degrees because it's the tangent there. It's a tangent that we have there. Obviously, then your third angle will be equal. So that's how we show similarity. Don't say the angles are equal. You must show which one is equal to which one. They ask this quite often. Ten minste 2. Jy moet this Q and Q is common. This is 90 degrees, so obviously O and R will then be equal. Yeah, but show which angle is equal to which one. They love this question. Yeah, well, usually you will get your 2 marks there for the 2 angles that you can show. Oh, the third one is automatically the same. But don't just say angles are equal. Which one? Which one? Then they say, find the length of OT, the radius of the circle. Now, hence means I need to use similarity. Okay, but let's first now look at this picture. What is equal to what? There's a circle inside. I hope you can remember what we did because we did this question. Okay, so this one is 13. This one is 10. So this one can be 5. Here, because this is the midpoint. Right. Now, what I want to know now, what is the length of this one and this one? Why? Yes, yes, yes. This one is also 5 because 2 tangents from the same point are equal. This one is not. It's not 6.5 because that's what the learners tell me, half of 13. No. 2 tangents from the same point are equal. So this one will be 8. And what about QS? QS? Wat gaan QS wees? Hoe? Met wat? Okay, so 13 squared minus 5 squared is equal to 12. Okay. Ek gaan, maar ek moet nou eers die sye kry om die similarity te gebruik. Jy is heeltemal reg. Maar but I need to. Kyk net hier vir my. Die groot fout is learners say this one is 6.5 and it's not. Omdat hy lyk of hy in die middel is hy nie in die middel nie, né? Look at the facts that we have there. So from there I'm going to use similarity now And the 66, so the similarity is going to say, so ek gaan nou net hier vir julle skryf watter sye oor watter ene. So OT over 5, let's just see if you can see it. OT over 5 is equal to 8 over 12. So I had to get those sides first. From there it's easy, cross multiplication, and then so I get that OT is 3 1/3. OT. But it was difficult here for the learners to see which sides. Again, they used an old question. Right, let's go back. Question 65. Yeah, also an extended, 65 and 64 are old extended questions. So, if they can do it, you can do it. The figures in the diagram shows lengths in units. For each of the 4 diagrams, write down the fraction of the total area, yeah? Hoe kom? Ag nee, Louis, nou maar moet ek jou weer terugkyk. Okay, kom ons kyk nou. Waar, is reg. Ekskuus, ek moet nou net op die oorspronklike kyk. So I say OT over 5, nou wat sê is verkeerd? Nee, jy werk met die ander 3 keer, onthou daai 2 goed draai om. Hulle draai om, né? Daai 2 goed moet omdraai, daai 2 driehoekies moet omdraai. Maar as jy sukkel met dit, dan moet jy hulle met tracing paper maak, dat jy kan sien daarso. Ek dink is reg nou, maar werk uit as jy stry. Okay. Stry, okay. Right, the next one, so we're looking now at question 65. Kom ons kyk gou na daai ene. So what would you say, what area is the shaded one, the first one? Is? Diagram 1 is a quarter, yes, thank you, that's right. Number 2, what will that shaded area be? Ja, ek het nou die antwoord gehoor. 1 out of 8. Because can you see that a parallelogram, 2 triangles forms a parallelogram? So that's why it's a half of this one. That's what makes it 1/8 there on that one. The parallelogram, a parallelogram can be cut into 2 triangles. So then you can actually draw 8 triangles in there. That's why it's 1/8. Perhaps it's a good idea to draw them also to see and find them there. Okay. Right, number 3. Hoekom? Hoor Anina se verduideliking, sê weer. But again you will be able to divide it into triangles there. It is then 3 out of 8. 3 out of 8. You can also look at that, this is the half of that side, isn't it? So this will be 4 or a half of it. And this is then 3/4, so it's a half of 3/4, and this is how I get the 3/8. Can you see? And then the last one, for each of the 4 diagrams, write down the fraction of the total area. Again, look at that little triangle there at the top. If you draw triangles in here at the bottom, if you draw that size triangles in there, then you get, then it's 3 out of 5 triangles there, 3 out of 5. So the best was to draw them in there. Ja, binne inteken. Maar goed, onthou nou, julle het nou nie kans om dit lekker deur te lees en 'n bietjie te deurdink nie, dis kom dit vir jou nou moeilik is. Ek gaan nou bietjie vinnig en jy het nie regtig kans om te dink wat om te doen nie. So dit is miskien maar nou net hoekom maar ons probeer nou maar net vir jou vinnig daar wys. 64 is, ek dink hy kom uit 1994 van Extended, daai vraag, maar 'n lekker enetjie. Okay, show by calculation that an equilateral triangle, a regular octagon, and a four-sided polygon gives you that angles there 360 degrees. So you just have to, at that point X, yeah, you just have to calculate all those shapes, isn't it? So what do you know about an equilateral triangle? It will be 60 degrees. What do we know about the octagon? 1080 divide by 8, so one angle is 135 degrees. Can you remember the formula? N minus 2 stadig times 180. And the last one is 24 minus 2 times 180. This is just because, remember, this is a show that question, is 165. And then if you add now all those three, you get the 360. Okay. So, polygons. This was about polygons. Right? Dis wat jy gedoen het, né? Luan, jy is heeltemal vry om dit te doen. Ek dink jy moet net wyse dan ook die interior angles. Verstaan? Jy moet net wys dan dat jy daai sprong maak na die interior angles toe. En jy het 'n skerp merker nodig om dit te sien, wat ek nie raak gesien het daai dag nie. Kon nie verstaan wat doen hy nie. Okay. Nee, so dit is nie verkeerd nie. Jy sal net moet teruggaan na interior angles. Anina, kom ons raak rustig. Number 63. The tangents PQ and PR are drawn from P to the circle center O. The tangent PR and the diameter QT are produced, dit teken langer gemaakt, to S. RQT is 34 degrees. Okay, now, this is all the circle geometry, all those rules on circle geometry. Can you remember that you learned that the angle in a semicircle is 90 degrees? The tangent to the radius is 90 degrees. Two tangents from the same point are equal. Angles on the circumference are equal. The angle at the center is twice the angle at the circumference. And your cyclic quadrilateral, where we say that opposite angles are supplementary, 180 degrees. And this exterior angle is equal to that opposite one. So that's your circle rules that you have to look at and what we're going to use here. Okay, what is PQR? PQR. Yes, because it's the tangent there to the radius, so it will be 56 degrees. And then RPQ. 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 You need to find S. You need to find the angle S. No, what is S? The angle there at R is 90 degrees. Yes. Nee, maar dit is die angle in 'n semicircle. Okay, kom ons kyk gou hierso. Ja, ek weet, ek probeer net wys daarso. This angle is 90 degrees at R. This one is 34, so you can calculate that angle. And, ja, dit gaan nou ook nie help nie. The exterior, R and Q. Is it two tangents from the same point? Ja. Nee. No, but look, these angles are equal. There. Not there. Yeah, those angles are equal, but not that one. Yeah, R is 90 degrees. Yeah. Yeah. Ja, maar onthou bietjie S is outside the circle. Ja, Jy kan dan al daai een So if you calculate it, you get that S is 22. As jy nou daai calculations maak, dan kry ons dat S is 22. Yes, and now you can go back in the big triangle. Now you can look at the triangle that I use now, PQS. PQS. So then I got that angle is 68 degrees. Ja, maar ons probeer ons maar net verduidelik, hoe kom jy daar? Ja, sê hom. Ja. Ja. Oh ja. Oh ja. Yeah, that's much easier. 180 minus twice 56. Yeah, that's right. But it also gives you 68, but that's actually much easier. Yeah, shortcut. And then the last one, SRT. SRT. Ons het nou al dit gesê, it's also 34 degrees. Yeah, we said that already. Okay, let's look at the previous one, number 62, very similar to the one that we have now, 62. ODC, find, okay, so you've got a circle there with the points there, AD is the diameter, COD 76, AB is parallel to OC, so we'll use all those facts. What is ODC? ODC. So it's an isosceles triangle there, 180 minus 76 divide by 2, and ODC is then 52. That's right, I hear the correct answer. Yeah, it's in, skryf het sommer daar op jou worksheet. Nee, that's in an isosceles triangle. And then ABC. Now, ABC and ADC are supplementary. It's a cyclic quadrilateral there. Can you see? So, what is the ABC then? 128. 128 degrees. And then the last one that we have to calculate is ACB. ACB. And then you will have to use parallel lines. Yeah, what will you say? Okay, use your parallel lines there. So what is ACB? Yeah, so 180 minus 128 is, but then you still, and then you still have to subtract something else. Uh-uh. 76, 52, 52. This one is 104. This one is 76. Yeah. So I can find this angle to be 38 degrees. And that's how you will get that this one is 14. That one is 14 there. Because look, the angle, kom nou, the angle there at C is 90 degrees. Nah. So 90 minus the 52, this is 38 gekry het, né? Here's a semicircle. This angle is 90 degrees. That's how I got the 38. And then you can calculate that angle at C to be 14. 14. But you can also use your parallel lines there to calculate of those angles there. Because the angle at C, this two will be co-interior. So then we can also say that it's 180 minus 128, soos Luan gesê het, but then also minus 38. Then you also get that one, co-interior angle. So the parallel lines have to be used. And then the last one, they say X is a point on AD such that AX to XD is 1/3. Oh, sorry, 1 to 3. Given that the area of the triangle EAD is 96, what will be EXD? Now again, what do we know if the area is in the ratio 1 to 3? The sides is in the ratio 1 to 3. What will happen to the area? Ja? Nee, dit gaan nie met hierdie ene werk nie. By die previous one. Ons kry net nog gekleer. Ja. Hierso, ja. Kyk, ek het hier probeer wys, die hele angle is 76, so wat jy nou sê is hierdie enetjie, is eintlik dan net 38. $76, ja, dan gaan hy ook 38 wees. Ja, the whole angle is 76. Nee, maar ons moet ACB kry. Hoppiekie, ons moet ACB kry, ons moet hierdie hoekie kry. Maar, hoekom is hy nie 128 grade nie? Hy is toch supplementary met die? Nee, dit is. 1, 2, 3, 4, maar as ek vat A, B, C, D, dan is dit 'n cyclic quadrilateral. Dan is dit 'n cyclic quadrilateral. Nee, maar ek kan die E ignore, en dan kan ek sê A, B, C, D is 'n cyclic quadrilateral. Nee, maar dit maak nie saak nie, dit is 4 points on the circumference. It's 4 points on the circumference. Ek sal nou 'n bietjie check of dit weer 'n dubbelsinnige ene is wat op 2 maniere kan werk, maar ek is seker dat soos ons hier geredeneer het, this is an isosceles triangle, this is 52, that opposite one is a cyclic quadrilateral, so that is 1 to 8. Ek sal net kyk, partykeer is dit so dat hulle verskillende inligting gee, maar ek dink as ons op hierdie manier dit bereken, is dit so. Hy sê nou as ons in hierdie driehoek werk, dan wil dit nou nie weer werk nie. En dit gebeur partykeer dat hulle sulke dubbelsinnige, ek sal hom net check. Maar ek dink tog AOC en nee, dit kan jy nie doen nie. Because the points must lie on the circumference, maar ons het mos nou met D gewerk. So D and B are supplementary. Hulle is definitief supplementary, Louis. Ek dink daar is ons is reg. Ek hoor wat jy sê, ek sal hom nou gaan uitcheck gou daai ene, maar jy kan sê B en D is, ek dink dit is heeltemal reg daar om te sê 1 to 8 degrees daarso. Ek sal nou weer daai hele een uitwerk. Kom ons gaan so 'n bietjie aan met number B. This one is not, I cannot in this case square the ratio. That's not going to work. So this is actually like sharing. So the big one is then 3/4 of 96, and that is then 72. Or actually this, here. What is the question? Calculate the area of EXD. They have EAD, that's your big one, which is 96, and then EXD is smaller. It's 3/4 of that line, can you see? So of 96, and the answer is then 72. 72. Okay. Kom ons kyk bietjie na 62. Here was also lots of mistakes on 62. 62. This is one with limits of accuracy. They combined it with limits of accuracy, and lots of learners just ignore that. The diagram shows a plot of land in the shape of a sector of a circle. The radius is 20, correct to the nearest meter. So what does that mean? 20 plus or minus 0.5. So your limits is 20.5 and 19.5. And then they say, and the angle of the sector is 50 degrees to the nearest 5. So what will be the limits there? Plus or minus 2. Yeah, so it's 52.5 and 47.5. Look at those limits. As I say, lots of learners ignored it here. The perimeter of the plot is fenced. Calculate the maximum perimeter. So, what is the perimeter? Yeah, it's these two sides, which is 20.5 and 20.5, but do I have the arc length? Do I have that arc length? And how do we calculate arc length? Theta over 360 of 2πr. So we first have to do that. And then we can find the perimeter. Okay, so it will be... ons net eintlik kyk watter jaarsin is daai ene, Louis? 16. Okay, ek sal nou daar gaan kyk na daai ene. So this is then, so now I take the maximum, so it's the upper bound, 52.5 over 360 times 2p, and what is the radius? 20.5. Okay, and then that's the arc length, and then I still, a lot of learners also forget these two sides, so plus 2 times 20.5. Anina, what is the answer? Sy luister nie. Michelle, kom, jy is nou met ander goed bezig. Ja, 50, I got 59.8. Ja, en dan het ek hom seker geround off na 8 toe. Nee? Maar moenie worry nie, dit kan met P wees wat daar slight difference is. It's the use there that plays a role. Hulle neem dit in ag daarmee dit. Maar look at the limits of accuracy, want soos ek sê, baie het dit vergeet, heeltemal the limits of accuracy. Right, the next question is now number 61, wat ons nou al gedoen het. Nee? Kom ons gaan 'n bietjie terug. 60 is again about similarity. Number 60 is again about similarity. The diagram shows two triangles. They have the sides, you have the sides there and the equal angles, and that's how I know that this is similarity. Calculate the length of PQ. So when we want to calculate this, it's now question 60, that one that you want to calculate, we put in the left-hand top. PQ corresponds now with which side? 3.6, isn't it? And on the other two sides, you find your ratio, so that's 3 over 4. What will then be the value of PQ? Good, yes, vinnig. So PQ is equal to 2.7. Okay, similarity. Then calculate the area of triangle ABC is that. Calculate the area of APQ. So what is our ratio now? 3 to 4. What do we do with area? We square the ratio, so it's 9 to 16. And the big one is 5.6. So what is this one going to be? 3.15. Kom, waar is jou kop, Luan? Jy nie meer uit jou kop uitwerk nie. Jy nou verstaan. Ja? Okay, the answer is 3.15. Okay, question 59. Given that ABC is a regular pentagon, calculate the angle. Dit kan julle doen, né? Pentagon, dis baie maklik. Look at question 58. There's a construction with Loki on graph paper. Hulle kan maar weer so ietsie weer 'n slag vra, né, maar dis baie maklik, né? Dit julle sukkel gewoonlik glad nie daarmee nie. Ons het na die Loki gekyk, so ek dink dit is okay. Goed. Question 57. Nee, dit is nog nie tyd nie. Hierdie vraag kom ook uit 'n ou vraestel uit. Ek kan nou nie onthou watter ene nie, maar hy is baie maklik. To celebrate its centenary, a city planted apple trees, and orange trees on a rectangular strip of a land 4 meters wide and 6 meters long. Wie my afval. The trees were planted in the pattern shown for the full length of the plot of the land. Calculate the number of apple trees and orange trees. Orange trees. What we had to see there is that, can you see that if this side is 5 and this side is 4, that one is going to be 3. So we had to calculate this. And then you just calculate the apple trees and the orange trees. But look that there's an apple tree right at the beginning. which you forget to add. So we have to add another one. So it's 101. And then the orange trees is 100. So you will just look in a 600 meters, how many of, this is 666 that you get there, that you will calculate that. Ja, nee, maar daai ene is 'n extra een, want jy begin by die begin, né? Look at number 56, the flower. Wag, ons gaan nog so bietjie, ons sal nou ophou. Ja, daai blom, en as jy weer terugkyk, daai blom was gevra. As jy toe terugkyk, sal jy sien hoeveel van die goeders is oor dieselfde. Die blom was, weet nie, hy was ergens al gevra. Weet nou nie waar nie. Okay, so calculate the size of OAB. This question is mixed with trigonometry. Wil julle ophou? Want ek is nou bereid om nog aan te gaan. Louis wil nie meer nie, en Anina wil nie meer nie. Kom, ek sal nog 'n halfuur aangaan. Nee, nie almal nie, net van hulle. Wil julle nog aangaan? Ek sal raar. Nou okay, die wat wil kom ons gee my die 2 minute om iets te sê, dan die wat wil gaan kan gaan. Ek dink jy moet hom stop, laat hy dan nou maar nie verder opval nie.
Omba Arts Trust is not just an organization for me. I think of it in the form of a person, a mother and a friend I have walked and grew with. A friend whom I've traveled many remote and dusty roads. A sister who provided so much needed support during times of fear and uncertainty.
Kamang ake kumta akwa kama kali khatani umwa ukaba kaharasiko ham qaton ikake mukashen kubiya umma qaqausin anhiya anhiya tigara wako ogo musa omkazwa kai na mkazwa kai kuku akan kete kaka kwase aka kwase to kudu aka kai tani duchi sake kubuka kana borka kana kumka thank you.
There is a saying in Damara for people such as Omba, which is which simply means someone who will, with love, exchange your lean piece of meat with their fat one. It might sound simple when translated, but when used towards a loved and appreciated person, it gives such honor. It describes a person who will do everything to make sure you are taken care of. Besides, we all know how the Damaras love their meat.
Let's see, Maria. Good. Johanna moet 'n bietjie meer regheid wees, né? Soos die boere hulle mielies plant.
Ja.
I have seen Omba grow and turn into a light of hope for Namibians all over Namibia. I have seen women and men grow as individuals, becoming respected members of their communities, but also valuable providers of their families. I have seen people with no hope in their eyes light up when they see Omba arrive to fulfill a promise which was made and which they did not believe will be kept. I have seen women dance and sing for hours until the dust from their feet covers us all because the old friend has arrived. I've seen women standing up in front of a large number of people and express their hopes and dreams. I've seen people who have never left their village travel hours and hours to other countries and share their culture and experiences. I have seen children grow and become young women and men before my very eyes. Omba has been the sister holding hands throughout it all. Omba has built valuable and strong relationship with communities, empowering both women and men, but the impact on women can be seen and felt most sincerely. The work with the women has such a ripple effect all over the whole village, most especially the young. Omba has taught them to fish. As times grow tougher and much more difficult, money becomes scarce. Environment around us changes and nothing will ever be the same again. In times like this is when we realize the value of a friend like Omba. It provides hope, constant support, reliable income, and keeping us all together, keeping our pots filled and our fires burning. A motivation to do better, live better, and expect better. If one day the unthinkable happens and Omba is no more, it will be a sad time for our Namibian rural population. Therefore, let's keep the light burning at all cost.
Ons die Sanmense is die eerste mense in die wêreld wat vandag agter gaan staan. Omba is nou die water wat vir ons nat maak. Dat onze wortels mooi groeien, dat ons vruchten kan brengen, kos kan brengen. Omba gee vir ons werk. En van daaraf lewe ons.
It's just an amazing story that ostrich eggshell beads, 72,000 years ago, the ancestors of the San were making ostrich eggshell beads, and today in the 2020s, Junko women are still making those beads pretty much in the same way. And the work has evolved from fairly traditional products. This probably would have been worn like this, into something as sophisticated and contemporary as this necklace from the waterfall range. So here we are bringing the necklace to this gallery in Windhoek, and it then gets sold to customers in Europe and America, and generating income for women, Junko women back in the Kalahari. So it's just an amazing thread of history that goes to this ostrich egg, to this contemporary jewelry. This basket I absolutely love. It's a finely woven basket in natural dyes. This asymmetry is very unique to Namibian baskets, and we've been working with these women, doing workshops and helping them evolve into these incredibly fine baskets. We've worked with the women developing different palettes, and there's another one with a slightly more yellow palette, but considered are the best baskets in Africa. What we're showing you in this short video is really a long journey of working together with rural communities, reviving ancient traditions, turning them into contemporary world-class products, and supporting the livelihoods of over 400 artisans. Even during COVID-19, we've been helping our sand communities with food and a distribution of tibby taps. What we need to do now is to honour the trust that has been put in us over the last 30 years, to support marginalised sand communities and the livelihoods of rural women around Namibia. Your donation will help us get our 400 artisans back to work as soon as possible so that they can feed their families. The lives of their 2,000 family members will directly benefit from this. Please help us raise $50,000 by contributing to the Umba Artisan C19 Support Fund. No matter how big or small, this will make a difference in the lives of our artisans during COVID-19. Thank you.
Hi beautiful souls, this is Nikita Winkler and I am here to share easy tools for stretching that you can do just about anywhere. This is a demonstration, so what's most important is that you take enough time that your body requires to release the amount of tension that you have. So let's get started. In this session, we will do neck stretches. I'm going to show you rotations, full rotations, you can do half rotations, and we're going to add a bit of tapping just to release the tension even more. Alternatively, give yourself a massage. If you have a lot of tension, go for the massage first before you do anything, just to warm the muscles, and let's get going. Full rotation. Releasing at every angle of this rotation. And I'm going to reverse, go the other side. All right, we'll do a half rotation. And then I'm going to just stop for a static stretch. Take the arm over the head, relax the shoulders. Drop the other arm, or alternatively, to deepen the stretch, take it right behind. Hold and release. Change to the other side, arm over the head, release the shoulder, let the weight of the arm pull you into the stretch. If you want to go deeper, take the arm around, relax the arm at the back, and release. One more to the front, interlace the fingers to the back of the head, lean the elbows forward, and release. If you're feeling a lot more tension, either go for the massage or just do some rotations. And that's it for now. Thank you for joining me. Happy stretching, and don't forget to breathe.